Are natural disasters increasing or decreasing? This is Steve Gorenham. Let me put here this slide. This is slide. You can see in this slide some details about his profile. Executive Director of Climate Science Coalition of America, author of several books. One of his books has over 100,000 copies in print. It's an impressive number, really impressive. So welcome, Steve Gorenham, to the podcast. It's a pleasure.
Hi, Armando. Great to join you again.
Thank you. As you do not have the control of the slides you sent to me before, I just have this. They are ready to. If you ask to me, I can put the correct slide during your speech. Please ask to me to do that.
Okay.
Please let me start with something that's very curious for me, very, 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 because you mentioned in your last articles that the number of natural catastrophes is decreasing. What we hear here in Brazil is exactly the opposite. So how can you explain this assertive?
Yeah, it's. I wouldn't necessarily say they're decreasing. I sent you a recent study by two researchers in Italy, a scientist by the name of Almonte and Mariani, that published in the Journal of Environmental Hazards. And they said they looked at the disasters and the data over the last, I think it was at least about 50 years until mid last century. And they concluded that from 2000 to 2020, we've actually had a decrease in natural disasters.
Do you have a slide for these numbers? No.
I don't. I do have one of the, if you put up the other one, the first one about the World Meteorological Organization. Now, they still say that disasters are increasing. This is a quote from this study. The number of weather, climate, and water extremes are increasing and will become more frequent and severe in many parts of the world as a result of climate change. And I think that probably is the prevailing view, but I don't think it's necessarily correct. And these scientists from Italy said that probably isn't the case. If you look at various sources of data, you don't see it either. By the way, the scientists from Italy said that the number of reported disasters rose throughout the end of the 20th century, but they attributed that to better instrumentation, better radar systems, better tracking of storms in the Atlantic with aircraft and things, better communications. But they said if you discount the improved communications and those sorts of things, that they didn't think storms are really increasing, despite what you read in the press and what they probably say in Brazil. But if we break down individual data, we can see that you look at a lot of data sources and they don't really show that the number of disasters is increasing.
This graph, just chart shows the number, worldwide number, or so United States only? I know worldwide.
Well, this is a worldwide number from MDAT, the emergency database, and they've been tracking for many years the deaths from disasters, and those have been declining. They're down about 90% since the early 1920s there, and they count all sorts of things, droughts and floods and hurricanes and heat waves and a lot of different things.
So from 500,000 deaths per year.
A decade, I think. That's annual. That is a per year. That's an annual number.
Okay.
In those decades, and now it's down to about a couple 100,000 a year annually.
Interesting.
Quite a bit lower. Now, the one thing that is rising probably is the monetary value of damages, because inflation drives property values up. We have more people living near oceans and other sorts of things than we had in the past. but the number of deaths is down. And I think if you look at particular storms, you see it as well. We can talk about hurricanes a little bit.
Mhm, mhm. Yeah, that's the point. Is from NOAA, from National Oceanic Atmospheric Administration. This.
Yeah. Yeah,
Okay.
I use their data quite a bit because what NOAA says usually disputes what's going on with the press. But
Oh, you
this is
have
just
numbers here. Oh,
well, that
is,
last one is just an image showing that there were no storms out there a few days ago.
is this one?
No, the first one. Go back to
This one.
that one right there. We were actually having a kind of a slow start to the hurricane season. Now they have predicted up to 15 major storms this year in the Atlantic Ocean. And now they've also changed those numbers too over the last few decades. They started counting storms that are way out in the Atlantic and never reached landfall. And it's made the count of storms go up. But typically we have either a tropical storm or a hurricane that shows up somewhere in the Atlantic by early June. And already we're late on that. The latest for not having a storm is about July 5th, I think. But we're later now than in the previous 10 years. Last year, if you want to go to the next slide, that shows number of hurricanes. Last year had one hurricane landfall in the United States. It was a pretty quiet year. And again, this is data from the National Oceanic and Atmospheric Administration, NOAA. You can go to their website and they list the name of every hurricane that has come ashore, made landfall in the United States since 1850. And so this chart counts those and reflects them. And it's interesting that we were getting about 20 hurricanes per decade 100 years ago, about an average of 2 per year. And now that's down to about 15 per decade, about 1.5 per year. So the number of hurricane landfalls has been declining, despite all the headlines that you see about and you hear about how storms are getting more numerous or stronger. We're just not seeing as many storms, at least in the United States. And then if you look globally, if you look at the next chart, we have scientists have been tracking global storms now. This is a global number for the last about 50 years. They use satellites to look down, and they can actually measure the wind speed of every storm on the surface of the Earth using satellites. And it produces these two curves. The top graph, the blue graph, is the number of tropical storms that are on the surface of the Earth over any 12-month period. And typically in 12 months, we have about 90 tropical storms on the surface of the Earth. The bottom gray graph is the number of stronger hurricanes. And we typically have about 40 or 45 of those in any 12-month period. And so if you look at this data and these graphs, they go up and down, but there's really no increasing trend for either tropical storms or hurricanes. And this graph is also a measure of storm strength, because if storms are getting stronger over time, more of those tropical storms would reach the wind speed to become hurricanes. And so the number of hurricanes would be rising, but it isn't happening. So there really is not a lot of evidence that storms are getting stronger or more frequent, but they sure are. They make great press. You know, it's a lousy headline to say we aren't having any hurricanes, but it's a great headline to say we have all this terrible weather. And so the press can boost readership by promoting disaster and alarms.
Yeah, but that's a good point. Before we go ahead, let me show that there are people following now. Jorge Oliveira from Lisbon.
Yeah.
Hi, George, thank you. But what's the reason that the press, media, are forcing the perception of the worst scenario?
Well, we have a number of things. One is we have a powerful ideology that I call climatism, that says that humans are causing dangerous global warming. And then we have many, many groups that say the storms are getting more frequent. By the way, the United Nations Intergovernmental Panel on Climate Change does not see evidence of that yet. They say we don't see that evidence. There are people like the UN predicting the storms are going to get stronger, but we don't see it. We also have much better communication, as you know. We have much better tracking. We have, for many years now, we've had planes flying into storms and tracking them, where back in the early 1900s, people didn't even know a storm was coming until it came ashore. There was no prediction. So I think there's quite a bit more of that now today. But it is, but you know, they've started naming every storm too. I'm not sure what they do in Brazil, but we're naming cold snaps now, and we're naming heat waves. I mean, it's, you know, everything's got to have a name now, and so it's really something that's become much more politicized.
Yeah. We do not have this kind of storms here in Brazil. It's a different climate, totally different from Gulf of Mexico, and you have a situation of the United States from Pacific, Atlantic, and Gulf of Mexico coming.
Yeah,
storms.
yeah. The United States and Canada get about 90% of the world's tornadoes because we have the warm air coming up from the Gulf and clashing with the air from the cold coming down south, creating tornadoes and creating storms. Although you did have some big floods in Brazil, right?
Right. In the south part of the country, especially. Yeah, we had one very strong 1 or 2 months ago, very, very strong floods.
Yeah,
sorry.
Go ahead.
No, I would like to ask you about oil companies. We heard that they are being forced to pay for climate damage, and I cannot understand exactly this significance of this process, because are they responsible for floods and for storms and things like that?
Well, that's what a lot of people are trying to say. We've actually had, I think the United Nations documented that we're getting about 18,000 lawsuits that are in progress over the climate. About 12,000 of those are in the United States. So we do most of the world's litigation on climate, but we have all sorts of groups and cities that are suing. Oil companies are a target. We've had this recent one. We've had City of New York, City of Chicago, San Jose in California, San Francisco in California, cities and counties in Colorado, all suing oil companies, trying to get damages with the claim that oil companies are causing dangerous climate change. We've just had the state of Vermont passed a law requiring oil companies to pay for damages for weather events. Vermont had a big flood last year, but some have pointed out that they had a bigger flood in 1927, and they had dozens of people die in 1927 from a flood in Vermont, and that's before we had much of an oil industry.
The reason could be related to CO2 emissions and things related to that.
Yeah, that's the whole idea. The idea is that the burning of oil, burning of natural gas, burning of coal emits carbon dioxide. Carbon dioxide is a greenhouse gas. It enhances the greenhouse effect. It causes the planet to warm. And then they claim that all these disasters are occurring because the planet's warmer. But you really don't see evidence of that, as we mentioned. By the way, let me talk a little about this litigation. There has never been a case that I know of that has been successful in getting damages from the oil companies, monetary damages. The courts have all rejected those. And what the state of Vermont has done, is probably going to be overturned in the courts as well. Where legal suits have been effective is when individuals or groups sue the governments. They've sued state governments and won. The court forces the government to take climate change into account. But there haven't been any monetary damages that have been exchanged yet. So I think this law in the state of Vermont is not going to work. But again, floods and droughts are another thing to discuss here. So I don't know about Brazil, but if you look at the United States, one example is the Great Plains drought of 2012. which was a big drought through the plains, all the way up into Canada. 80% of U.S. agricultural land in the southern 48 states in the continental U.S. was in drought. Dr. James Overpeck of Arizona University said, quote, "This is what I and many other climate scientists have been warning about. This is what global warming looks like on a regional or personal level." But again, taking data from NOAA, and you can go to the next slide.
Yeah, sure.
NOAA uses a metric called the Palmer Drought Index, and they've been measuring it for 100 years or so. And it produces two graphs, one that shows the portion of the United States that is very wet in any year, and the portion of the continental U.S. that's very dry every year. The wet one is the top green graph, and the brown one is the dry portion of the U.S. And again, if you look at these, there's really no trend of increasing drought or flood. We've had many periods of wet and dry over the past 100 years. And that red arrow, though, there shows 2012 and the drought that Dr. Overpeck was complaining about, as he said, is due to man-made warming. But if you look back over the last 100 years, you can see many, many periods, dozens of periods when the drought was about the same or even worse than in 2012. And many of those years were far earlier. Humans didn't really start emitting significant amounts of carbon dioxide until about World War II and after. It's been very, very small before that. So again, no trend of increasing drought and flood. But people think, I've never seen a drought like this before in my lifetime. This has to be something strange. Something must be causing it. And they don't realize if you look back through history, you see comparable periods. Earth's weather is quite variable, and it changes all the time, and it produces droughts and floods and heat waves and cold snaps just on its own. And really, these things are not caused by power plants or sport utility vehicles.
It's interesting. You mentioned Brazil 2001 and 2018. 2001 was very strong, the process. We start doing thermal gas stations to replace the hydro stations, because 70% of Brazil electricity is from hydro. And
yeah, okay.
And when the rains, we do not rain, so we have a strong problem. So natural gas thermal processes are the solution we have. But we have a very low frequency problems like this one, as you had in 2012, you mentioned, no?
Yeah. Yeah, we get a drought every 4 or 5 years. And really, I think globally, droughts are considered the worst disaster in history. They would kill the most people, and you'd have crop failure and a lot of other things. So it's always nice when you get some rain during the year.
Yeah, that's
Although
right.
sometimes floods are pretty bad.
What are the gases that we consider the pollution vision? CO2, methane, and nitrous acid?
Nitric acid.
Gas.
And the biggest one, the biggest greenhouse gas, of course, is water vapor. And most people don't know that, and that's often not counted.
You mean the clouds?
Well, water vapor and clouds absorb outgoing infrared gas. Outgoing infrared radiation, and then it makes the molecules vibrate in the water vapor, and then or in the carbon dioxide, and then they re-radiate that when the gas cools down, and that does tend to warm the surface of the Earth, and that's what they call the greenhouse effect. But water vapor is the dominant greenhouse gas in the atmosphere, accounting for something like 70 to 90% of Earth's greenhouse effect.
Wow.
And
much more than CO2.
Much more than CO2. I mean, there have been some scientists that said, he could have more impact by spitting than measuring carbon dioxide because water vapor is so large.
And for
people don't realize that.
Yeah, and for these polluters, are there something in terms of regulation that the Environmental Protection Agency are planning? Do you know about something about that?
Oh yeah, well that's where we've gone off track. By the way, I don't call carbon dioxide pollution. Carbon dioxide is an odorless, harmless, invisible gas. It doesn't cause smoke or smog, and it makes the plants grow. But let's go on and talk about the third most important. So water vapor first, carbon dioxide second. The third most important is methane.
Mm-hmm.
And we have a war in the U.S. going on with methane now. The Environmental Protection Agency has just passed rules for the oil and gas sector targeting methane emissions. And methane, of course, is natural gas.
Mm-hmm.
So when we get natural gas out of the ground, this natural gas or methane escapes from pipes or unclosed off wells and goes up into the atmosphere.
But this is not common. This is something rare. This leakage
Well,
of methane.
it's very small. It accounts for something like 6% of the greenhouse effect.
Mm-hmm.
But you hear over and over, at least in the U.S. press and in Europe, that methane is 30 times more potent in warming than carbon dioxide, or 80 times more potent in warming. Those things are really incorrect. That they are correct for in the laboratory. That methane will absorb that much infrared radiation, but not in the atmosphere. And the reason is, and I like to ask, when I speak in front of a group, I say, does anybody here paint a room in their house 10 times?
Mm-hmm.
And of course, nobody does. That's because after 2 coats of paint, you really can't see any difference. And the same thing is occurring with methane in the atmosphere. Methane is saturated in the atmosphere. You can put up the next slide if you want.
Sure. Yeah. Here.
This one's a little complicated. This is a slide from Will Happer at Princeton, a scientist who's an atmospheric scientist who's an advisor of mine. And it shows on the vertical axis the outgoing long wave radiation, which is also called infrared radiation. And along the horizontal axis is the frequency of that radiation. And so it shows a spectrum of outgoing infrared radiation. And then those curves indicate how much is affected by the greenhouse effect. The top blue curve is the outgoing infrared, just from a warm Earth, if there would be no atmosphere, if there's no greenhouse gases in the atmosphere.
Mm-hmm.
And then as with carbon dioxide in the atmosphere, it's reduced to that black curve. And in other words, less radiation goes out, which means the Earth warms a little bit. But the greenhouse effect is a natural factor. Most of that carbon dioxide is from nature, not from human industry.
Mm-hmm.
And then I think you can't even see it on the chart here, but methane is very, very tiny. There's a little tiny red spot at about 1,300 per centimeter, the frequency.
Mm-hmm.
That would be what would be the change in these curves if you double, either from natural or man-made causes, atmospheric methane. There's almost no change. It's like nothing. Again, because methane in the atmosphere is already saturated and at the frequencies at which it would absorb infrared radiation. So we have all these people running around trying to say, well, we can't have it from oil wells. We can't have methane emissions from cattle or pigs. And it's just very, very foolish. It isn't going to have any effect. The only thing it's going to do is raise the price of food and raise the price of energy. But not going to affect global warming at all. Nevertheless, the government's pushed forward with this. It's just another thing in the idea that humans are causing climate change that is flat out wrong. Very, very unfortunate, but here's where we are. Anyway, if your listeners hear that we got to stop methane from going into the atmosphere, just realize it's saturated out there and it's not going to make any difference.
Mm-hmm. Mm-hmm. Tell me about Canada. What's going on in Canada? Because I heard that they are saying that pollution is affecting young people, the competence, the capacity to develop people. What does it mean? Yeah,
I saw this headline the other day that I sent to you. There's a group called Canada's Report Card Research Committee. It's a government committee. And they just issued a study that was titled Report Card on Physical Activity for Children and Youth. And they said that climate change and warming temperatures in Canada are impacting the children's ability to lead healthier and more active lifestyles.
Mm-hmm.
And I'm thinking about this, and I conclude that this is one of the goofiest, silliest studies of the year. If there's going to be an award for the silliest studies of the year, this one ought to be right up there as a contender.
Wow.
So in Canada, in Toronto, the average temperature is 8.7 degrees Celsius.
Mm-hmm.
In Rio de Janeiro, it's 23.6 degrees Celsius in a year. So I have to imagine that none of the kids in Rio are getting exercise.
No.
They're all
Sure.
The climate
it's totally opposite.
The climate is making sure they don't get any exercise. I mean, it's just the silliest thing to say that if Canada warms a little bit, it's going to hurt the physical fitness of all the kids. I mean, this is just beyond common sense. It's one of the goofiest things I've read in quite a while.
But is that a scientific study, this one, or?
I'm sorry?
Is that a scientific study, this one?
Well, it's a government study, and
okay.
I don't know.
Yeah,
it's just crazy, all these things that I talk about these in my book, A Green Breakdown, all these crazy things that are going on. I mean, there was a study in a headline in Florida that they said couples were cheating on each other because of global warming.
Mm-hmm.
So now you have an excuse, honey. The climate made me do it. There's another guy in an article in New York Times that said we should all mate with short people to solve global warming. I mean, there's just goofy things that go on and on and on.
Yeah. In your book, you said that you predict that the world's headed to renewable energy failure. But is my perception is the opposite. 99% of scientists say exactly the opposite.
Well,
how do you deal?
That's not really true. That 99% is trumpeted, but it comes from a bunch of surveys. The first one that did one of these was from the University of Illinois at Chicago, that asked two questions, if I can remember what they were. One, do you think the climate's warming? Well, they sent out 10,000 survey questions. Do you think the climate's warming? Well, anybody who knows what's going on think the climate's warming. So we'd all answer yes to that. And then they'd say, the second one was, do you think humanity or human industry is I think it said significant factor in the warming. It didn't say, is the climate dangerous? Do we have to reduce it? Do we have to do anything? Just, do you think it's a significant factor? Then they ended up throwing out like 9,000 of the 10,000. And then they reduced it further to just say, well, these people are climate scientists and these aren't. It was the opinion of like 130 people. So these things are really goofy. And there's some other studies like this too. So don't believe the 97%. The first thing I ought to ask is, and saying, is the climate warming? Well, everybody believes that as well. Climate change is continuous. The real question is it dangerous? And the further question is, can we do anything about it? And the answer is, the answer to the last one is probably no, because it's dominated by nature. It's dominated by water vapor as part of the greenhouse effect. It's dominated by ocean currents and what goes on with the sun and all sorts of other things. So we probably can't do anything about it except adapt to it, which is the only proper policy. And then the question is it bad for us? Is another one too. Warmer temperatures are good for humanity, as I think we've discussed before. There's less flu in warm seasons than cold. There's less COVID in warm seasons than cold. Less people die in warm seasons than cold. A little bit of warming temperatures is good. And by the way, where the Earth warms too, near the equator, there's almost no warming. In the temperate zones, like down by Montevideo, maybe there's a little bit of warming, and then most of it is down in the cold regions. That's where we get the warming. And so it's, again, a tough argument to say that that's really bad for society if the colder regions warm.
But that's a good point. Imagine that suddenly we can replace oil, coal, and natural gas or other products that do not emit CO2, methane, and so. it, it, it can modify something in terms of nature, climate, temperature, or not?
No, I don't think so. I don't think it will. We have, again, if you break down the greenhouse effect, water is first. Second is natural emissions from oceans and land. Human emissions of carbon dioxide from our industry only affect about up to 2% of the greenhouse effect. It's very, very small. We've had many warmer periods in the past than today, despite headlines that say this is the warmest on record. But if you go back 1,000 years, it was warmer for centuries at a time than it is today. I think I've talked about the Rhone Glacier in Switzerland, which is it's a mountainside to mountainside glacier. It's been receding for more than a century. But every time it pulls back, they find horse bridles and wagon wheels under where the glacier was, and wood that was 4,000 years old. And many scientists have pointed out that the valley was ice-free where that glacier is today for most of the last 10,000 years. So climate is dominated by natural factors. What we need to do is adapt. We need to build seawalls to adapt to rising oceans. We aren't going to stop oceans rise by everybody driving an electric vehicle. That's just not going to happen.
Yeah, interesting. In our last podcast, you talked about electricity in the U.S., electricity shortage, and you mentioned that something is going very bad in terms of electricity stability. Are you more confident at this time, or not yet?
No, we still have I've tracked this every day, and this is an image of that white building. There is a data center. Amazon just bought a data center next to a nuclear plant. So the question is, why would they build a data center next to a nuclear plant? And the answer is obviously to get electricity, but the bigger answer is it's to drive artificial intelligence. We have many firms now, the big ones, Microsoft and Amazon and Google and Oracle, Apple, that are doing artificial intelligence, and they use very high-speed computer processors that use lots of electricity. They're upgrading data centers around the world and building new ones. And so the demand for electricity in the United States is going to go up by about 20% within maybe 10 years. And it's going to be very, very difficult for us to provide that much electricity. Now, I think about 50 or 55% of the firms across the world that are doing artificial intelligence are based in the United States now. So this may be our problem, but other folks want to do this as well. I know they want to do this in Europe, and they have kind of a shortage of electricity in Europe. Go ahead.
No, please, you first.
I was just going to say, just in Indiana, it's been announced this year, 4 new big data centers by Microsoft and by Amazon. I think it's Meta are 3 of the 4. And these things the Microsoft one is 6 acres in size. It's very, very big. And these things are going to use a lot of electricity. Indiana has relatively low electricity prices now, and that's one of the reasons they're attracting these new data centers. But there's just no way that the U.S. is going to be able to continue closing coal and natural gas plants and provide the power output for these data centers. So that's going to come to a screeching halt. The green movement's going to be screaming about this. There's already a lot of articles. I have to start watching what's going on in Brazil. Maybe you can watch the headlines as well. But this could be a big increase in demand.
Yeah, that's right. A big increase in demand in electricity in Brazil, but we have a strong position in terms of electricity production.
You do.
It's not a big problem for us. Yes.
Hydro is really good, and it's
yes.
You do have environmental issues building the big reservoirs, but after that, it's non-polluting.
Exactly.
Relatively low cost.
Yeah.
And as long as you can augment it with some natural gas, as you mentioned, you should have
we have 7 or 10 plants, big plants of natural gas, and are increasing very fast the wind energy in northeast part of the country, offshore.
Okay.
That's not too reliable in terms of intermittence, but it's adding energy every time. But let me ask you about the shortage that you predict. What can exactly happen? Stop working the electricity production, or and when do you expect to have something like that?
Well, we're already seeing it, and we have. If you read the headlines from our electrical grid operators, they say, "Wow, we didn't know this big jump in demand was coming." It's been relatively flat in the U.S. for 2 decades, electric power demand. But now we have all these people near Washington D.C. and Virginia. The big firms have gone and said to the grid operator, "We need 2 gigawatts of additional power." That's like 2 new nuclear plants, very, very big. Many states are looking to build power. And what's going to happen is the big guys with these big contracts, like Amazon and Microsoft, are probably going to get their electricity, but then everybody else's rates are going to go up and that means EV charging stations. That means heat pumps if you want electric appliances, and those are going to go up in cost. And so they're going to be scrambling for quite a while, and they're going to stop shutting down coal and natural gas plants. They're going to stop shutting down nuclear plants. And so that's really what's going to happen. We are at risk of blackouts. The Federal Energy Regulatory Commission recently issued a summer reliability assessment and said that a lot of regions are vulnerable. And that's in part because we've been shutting down gas and coal plants for a while and trying to fill it in with wind and solar that are intermittent. But go ahead.
For when do you expect to have some kind of problems? You mean this year, 10 years, 20 years?
Well, could be this year. It depends on what goes on. Last year, Texas issued 11 electricity warnings.
Wow.
I'm sorry, 10 electricity warnings from summer to fall. And they said, basically, don't run your air conditioner, don't plug in your electric vehicle. We don't have enough electricity. So Texas is sort of on the edge. We have New England on the edge, but that's mostly probably a cold weather thing. But throughout the Midwest, there's potentially problems with having electricity shortages if we get severe weather or we get severe temperatures. And again, our grid margin has been shrinking. I think I showed a chart in the past. 10 years ago, we had the average electricity ratepayer in the United States had about 3.5 hours of outage a year, cumulative. But now, in the last 3 years, that's been running 5, 6, or 7 hours of outage a year. So it is rising, and we're kind of on the edge with the grid, even without the big new demands from electric vehicles and artificial intelligence.
But the United States has a problem with air conditioning because a big house and with 65 degrees Fahrenheit set in the summer, 110 degrees outside, 65 inside, and one person in the bedroom sleeping, and all the home being refrigerated. It's an efficiency problem, isn't it?
Yeah, some people set their air conditioners too low. And what I like to say is, when I present, we have about 700 million people across the world that don't even have electricity, another 2 billion that have blackouts or brownouts every other day. And so if you have an air conditioner in the United States, you probably use more electricity with that air conditioner than a third of the world's people get to use. So yeah, we use it very heavily. But electricity has to be there if people are going to demand it. If the system can't supply it, then you have a blackout and the whole thing can collapse. So you have to, what the operators do is they shut down certain areas for a few hours at a time, and then they roll that shutdown to another area called a rolling blackout. And if people are going to demand it, you have to be able to supply it. And you can't blame it on climate change like they want to do nowadays.
That's right. And every day more people are accessing electricity and air conditioning in the world. It's a very big problem, challenge for the world. I don't know which energies can solve this problem. Yeah.
Well, again, what we need to do is reduce real pollution. Not carbon dioxide. That means what we need to do is put scrubbers on coal plants and put catalytic converters on cars, remove lead from gasoline, work on those sorts of things. And we've done a lot of that, but not carbon dioxide. You know, Armando, if we live long enough, we're going to see a cooling period here. Might be a decade or 2 decades long, maybe 3 decades long, and
It's
then the
for you.
theory
That's a young guy. I'm old guy. No, I cannot.
could start tomorrow. You never know. The temperature is very tough to predict globally,
Yeah.
and if we get into that period, we're going to see the theory of man-made warming not doing too well.
Yeah, that's right. Steve Gottenham, thank you so much. It was a great pleasure talking to you today in this podcast.
Thank you, Armando.
Thank you.
So have your folks pick up a copy of Green Breakdown. Then go to my website, Steve Gorham, GOREHAM.com.
Let me put your book here again. Yeah, this one.
Yep. I'll send them a signed copy. It's a complete discussion of the energy transition, power plants, home appliances, electric vehicles, heavy industry, heavy transportation, the recent energy crisis in Europe. And it points out that people are going to demand a return to low-cost, reliable energy, and that we're never going to get to a net zero, at least by 2050.
Mm-hmm. And let me put again your, oops, one more here. Oh, yeah. Your website is this one?
Mm-hmm. Yes.
Yes, perfect. Okay. A great day. Thank you.
Thank you.
Thank you. Bye-bye.
Bye-bye.